Hi, today I would like to show you my voltage multiplier, high voltage cockroft walton voltage multiplier that can output up to 33 to 34 centimeters arcs at around, I don't know, maybe 160, maybe 170 kV, something like that. And yeah, show you a bit how it performs. Just to quickly go over the setup first, I have the mains that feeds my variac, which is 8 amp. Then it goes to step down MOT that can output something like, I don't know, 30 volts, 15, 20 amps. Then it goes to a full bridge, this one. Some filtering to try and not get a voltage that drops too much under load. Some measurements, classic eBay ZVS, which just converts the DC into high frequency AC. That then goes into this flyback transformer, which is AC as well. It's not like the ones you find in TV. This one I also found on eBay. Actually, I didn't have to wind it myself, which is good because winding a flyback is a pain. And then there's the tower. So as you can see, it's fully potted in paraffin wax, and there's the yellow connection for AC, white connection for grounds, and blue connection, which is just a measuring output based on Viduli's design. Actually, I should mention that if you know Viduli, you'll notice that all of my setup is widely inspired from his multiplier setup. So yeah, the one difference being that I use analog meter for high voltage. So I actually use the meter as being part of the resistor divider. So it's definitely not that accurate, but it's decent enough to get an idea of what's happening and to not overvolt the multiplier. Then everything is connected to this ground plate, which with this brown cable is connected to some water pipes. And the top I used a high voltage cable, and I have a pretty sharp needle so that it can easily break through. And also a chicken stick to discharge the multiplier when I'm done. Before building this big one, I also built a few smaller ones. This is a 5-stage with 1 nanofarad capacitors and 2 CL77 5mA diodes. And actually it works great. It can already output something like 12, 13, maybe 15 centimeters arcs. Or not that much actually, but yeah, something like 12 centimeters I think. But I actually found out that having 2 nanofarad stages increases quite a bit the output by like a few centimeters. And that's even just with 5 stages and also air insulated. So this bigger one is 2 nanofarad stages and bigger diodes as well, 2CL, 2FM, and it works great. Okay, for this shot I have the spark gap set at about 20 centimeters. And I've put the kilovolt meter so that you can see how voltage rises and also drops with the arcs, because I think it's pretty cool. We already have some nice corona. They're at about 10 kilovolts per stages, slowly rising. And you see that even though the corona is getting more intense, the voltage is not rising anymore. And now the voltage doesn't rise, but when we get enough, it drops slightly. Okay, now the spark gap is pretty much exactly 30 centimeters. You can actually see the thing in the back moving. Now I made the room a bit darker, so maybe we can see the nice corner a bit prettier. Alright, one more run, and just so you can see, like, this spark gap is quite massive. This is the side of my hand. Also, now that the tower gets to almost fully charged, the discharges are actually quite energetic, like maybe a few joules, 1 or 2. So I'm actually wearing ear protection. Yay! Alright, I don't want to stress my supply too much, so that will be it. But yeah, that was 33 centimeters.